we're going to learn about the law of sines. Okay? And the law of sines says that you see a sign that looks like a regular octagon and it says stop on it, you better stop.
Wait, is that supposed to be spelled?
Or you're going to get a ticket. And that's the law.
So it's always supposed to
If you see a stop sign, you better stop. And that's the law. That's the law of sines. Okay? I'm just kidding. So, did you know that? Law of sines. So I have some notes here. Okay? And so law of sines, when you get to pre-calc or maybe even algebra 2, you'll learn about what's called the ambiguous case. But in this case, we're only going to use law of sines when given an angle side, or an angle side angle, right? You can find all the other sides and angles. That's when you use law of sines. And this is for any triangle, not just right triangle. So where SOHCAHTOA sine, what we just learned, sine equals opposite over half, that definitely works for right triangles. Law of sine works for any triangle. So I like to kind of show people why it works, and so I'm going to try to draw a triangle. Uh-oh, here I go. Mr. Leader's going to try to draw a triangle. Let's see, make a triangle. Ah, very good. Okay.
Can you skip that?
And am I in the way?
Yeah.
Scoot over. Yeah, but then I can draw it from over here. And then I'm going to try to draw a height down. Can you see now? Okay. And I'm going to call this the height. Okay. And in a triangle, if I call this A, this B, and this C over here, you don't have to write this down. I just kind of want to show you where a law of sines comes from. Okay. If this is big A, what's this side called? What do I call this side? Little a. And if this is angle big C, this side is called little c. And if this is angle big B, this is called little b. Okay? Now, it so happens that the sine of C, the sine of C is equal to what over what? Well, if I drop this right down and make a right angle right there, is equal to h over, not A, h over B, right? And the sine of angle B is equal to what? Opposite over hypotenuse, h over c. Now if I do a little math here, and I multiply through by b, I get in this case that h equals b sine c. That's an b, that's a b. Okay? And oh, I gotta fix that because it doesn't look like a b, does it? That's a b sine c. And over here, still doesn't look like one. And here solving for h, I get h equals c sine b, right? Now using a little algebra, since this is equal to h and this is equal to h, what can I say about this and this? They're the same. So I could say that b sine c equals c sine b. And then what I could do is I could divide both sides by b and c. Why would I want to do that? I'll show you why. And divide both sides by b and c. C and c. And then what happens here? What cancels out from here? A b and a b, right? I mean, sorry, a c and a c cancels out from here. And what cancels out from here? A over b. And so what I end up with is that the sine sine of c over c. And if I drew this where I did the height going like this way, I could also show that that would be equal to sine of a over a. And that is called the law of sines. And what it says is that for any triangle, okay, the sine of one angle over its opposite side is equal to the sine of another angle over its opposite side, which is equal to the sine of a third angle over its opposite side. So basically what you could do, you don't have to have a right triangle. You could eliminate this h here. You could eliminate the middleman. That's what Tom Shane does. We eliminate the middleman at the Shane Company. That's what he says. Okay. Have you ever been to the Shane Company? Or that special someone? No? You haven't heard those commercials? Okay. Never mind. All right. So, how does that work? Example problem. Got it? Moving on. Moving. Say you have a triangle that looks like, I'm trying to draw another triangle. Can I draw a triangle? Let's see. Looks like this, looks like this. That's not, don't make it a right triangle. It shouldn't be a right triangle. Is that good enough? I didn't want it to be a right triangle, so I'm going to indicate that this is not a right triangle. This is 100 degrees right here. Okay? And this is 50 degrees right here. And this side is over here. This is 8 over here. And I'm going to call this side, this angle A. And I'm going to call this side A. And I'm going to call this side B. And I'm going to say, solve the triangle. Solve the triangle. And when they say solve the triangle, that means find all the missing sides and all the missing angles. Okay? And when you do that, it's pretty easy, I think, to find this angle over here. What's this angle? What's this angle? 30. First of all, make sure that you have enough info. Do you have an angle on side?
Yeah.
Yes. So there's only one triangle that can be formed here. So you have this angle, on this side. So these sides have to be a specific length. And so to do that, what does this have to be? 30. So yeah, just adding up. So don't do more work than you have to. Don't use a lot of signs unless you have to use a lot of signs. So you just by looking at the triangle and knowing that triangles add up to 180, that is 30 degrees. The hard part is finding A and B. So what I could do is I could say that the sine of 50 is to what? Sine of 50 is to its opposite side, 8, as the sine of 30 is to A. Okay? And then what I would do, I would solve for A in terms of these things instead of plugging things into your calculator first. So let's try to get A by itself. Okay? What would I do to get A by itself? Hello? Times through by A. So I'm going to multiply both sides by A. Okay? Multiply both sides by A. This cancels out, right? And, did I do that right? Yeah. And then I need to multiply both sides by 8. So I get A sine 50 over 8 equals sine of 30. Okay? And then I need to get A by itself. So what do I have to do? Multiply by 8 and divide by sine of 50. Okay? So I'm going to do the same thing over here. I'm going to multiply this side by 8 and divide by sine of 50. Okay? Because what happens, this goes away, this goes away, this goes away, this goes away. And I get that A equals sine of 30 times 8 divided by sine of 50. Okay? I just want to show you something on your calculator. Can I do that? Cool. Okay? So on your calculator, where's my calculator? I got all this junked up here. this on your calculator, be careful, okay? You want to do sine, is this sine? Sine of 30, okay? But then make sure you close that parentheses first, okay? Otherwise, it's going to take the sine of 30 times 8, which is 240, okay? Times 8 divided by, and I would just to make sure, put this in parentheses as well. So divided by in parentheses sine of 50, okay? Like that. Close that parentheses for the 50 degrees, and close that parentheses for the thing you're dividing by. And then if I do that, I get that this side over here is 5.22 or something like that. Okay?
Yeah.
I don't have too many parentheses. There's a parentheses for the thing I'm dividing by, and then there's a parentheses for the. Yeah. Yeah, that's what happens with these calculators. You gotta make sure you're using lots of parentheses. Now to find b, okay, I cannot just use Pythagorean theorem. Why not? It's not a right triangle, right? So I have to do a similar thing to find b. So to find b, I would go sine of 50 is 2/8 as sine of 100. Sine of 100 is 2b. And then when I solve that, I get that b is approximately equal to 10.28. I'm not going to do it. Okay? Okay? Yes, sir.
Why do you always use sine?
Yeah, a lot of signs it's always using sines, because the way we got that is, the way it was derived was using the opposite side and the hypotenuse, right? So that's why it's called the log sine, because that's where it came from. Okay, it's not like a right triangle which you could use anything. Okay, now what if I want to find an angle? Okay, so for instance, say I have another triangle. Where's my other piece of paper? Piece of paper. There we go. So I'm going to have another triangle. I'm going to draw a triangle again. Okay, it's going to look kind of the same because I'm not a very good triangle drawer. Does that look like a triangle? Kind of. Okay. Now just bear with me and pretend that these sides are what I say they are. Say this is 7, this is 12, and this is 30 degrees. And say I want to find, oh, I can't do that, can I? 7, 12, I gotta erase that because you can only use off signs when you have angle. Did I say this? Can you side angle, side? Oh wait, angle, angle, side. Wait, I don't need angle, side, angle, side. Side. Say I know that this angle over here is, let's say that this angle over here is 30 degrees. Okay? And I want to find this side over here. No, I don't. I want to find, can't do that, can I? Sorry. Say I want to find, say I know this angle is 30 degrees, sorry. Okay? And I want to find the other two angles, okay? And eventually the other side. So if you're given something like this, angle, side, side, they will tell you that this is an acute triangle, or, well, maybe they will. This won't be an acute triangle. But in this case, we won't have any, it's called ambiguous case. See how this is angle, side, side, or side, side, angle? That's called an ambiguous case. So really with this one, I have two answers. But we're going to pretend that we don't have two answers. So we're going to find this angle over here, which I'm going to call B. Okay? So you could say that sine of B is to what? 12, as sine of 30 is to 7. Okay? Now, I happen to know, I'm not going to use my calculator because I happen to know from years of teaching trigonometry that the sine of 30 is 0.5. Okay? If I plug that into my calculator, I get 0.5. Okay? And then I multiply, and I get sine of b equals 12 times 0.5, which is 6, divided by 7. So how do I find b? No, you don't divide by sine. You can't divide. Yeah, you go sin of inverse sine of 6/7 is equal to b. Okay, like that. That's the way you have to do it. Okay, so you go second sine of 6 divided by 7. Okay, and you get that angle up there is 58, about 59 degrees. Yes? And if that's 59 and that's 30, what would this one have to be over here? Hello? There, 59, 30, huh? 91 degrees. Okay? So they will tell you this angle that you're trying to find, it turns out it can be either an obtuse angle or an acute angle, but we're only going to worry about when this angle is acute, okay? Because it turns out that this could be 59 and this, or it could be 180 minus 59, but we're not going to worry about that for this stuff. Okay, next thing you have is one more formula, and you have where does this formula come from? It can be shown also. Where's my triangle? Is this my triangle tool? There's my triangle. How come it always comes out to look the same? Let's try to draw a triangle right there. How does that one look? Oh, that's better. Okay. I kind of wanted a lopsided triangle. Watch. Okay. So if I call this H over here, and this is A, and this is B, and this is C, and I'm going to call this side a little b and this side a little a. I know from before that the sine of A is, and I'm going to call this side C from here to here. Okay? How do I find the area of that triangle? What would I multiply? C times H divided by 2, right? Yes? But what you can do is actually solve this for H. And since sine of A is equal to H over B, I get that H is equal to B sine A. See that?
What is the sine of A, H over B?
Opposite over hypotenuse. Okay?
Oh, it's
Sine is opposite over hypotenuse. So now I can take this and I can plug it in to here, okay? And what I get is that A equals the area of any triangle is equal to A times C. I'm going to write this as A times C times the sine of that doesn't make sense. Yeah, that makes sense. It should be A times B. H.
What is sine?
A times C. Wait a minute. C. Opposite of, what happened to my B? C. Oh, sorry. Sorry, this should be B sine A, right? C, sorry, I messed up. B, C, sine A. So this is the area. So the area of any triangle can be found by multiplying this side times this side, dividing by 2 times the sine of the angle between them. Okay? So for instance, I just kind of wanted to show you where this came from. So if I have a triangle that looks 50, and if I plug that into my calculator, 400 sine 50, I would get that the area of this triangle is 306.41. Okay?